Assalamualaikum and very good day to Dr. Yati. Today I will be presenting with my group mates Alif Qusyairi. My name is Muhammad Hafiq about question 6 in tutorial 3. So for question 6, the question asks us to draw the shear and bending moment diagrams for the beam and loading shown and determine the maximum absolute value of the shear and bending moment. So as you can see, the diagram is shown as in the question, and we're moving on to the solution. Okay, so we'll be moving on to the solution. As you can see, we have draw the free body diagram for the question, and from after we find the moment at point C and point D, we can know that the moment have the same value, which is 3.75 Newton meter. After that, we complete the free body diagram where there is a reaction at point A and point B. So to find the value of reaction at point A and point B, we must find the total moment, which is we equal it to 0, and then we get the reaction at point B, which is 65 Newton. And then we use the equation that using to find the total vertical force at the beam, and then we substitute the value of RB 65 Newton into the equation, and then we will get the solution to find the reaction at point A, which is 85 Newton. And then we will have to cut the beam into 3 parts to find the shear force and the bending moment for each part.
Okay, for the first part, the range is between 0 to 0.25 meter and indicates as X. So here we calculated the moment 1 and V1, the shear 1, shear force 1. So for the moment, total moment, we indicate counterclockwise is positive. So we get negative 85x plus moment 1 equal to 0. So moment 1 equal to 85x. So for shear force 1, here we will calculate the total of forces. Okay, and the downward force is positive force. So we get negative 85 plus V1 equal to 0. So V1 is equal to 85 Newton. So for the second part, the range is 0 until 0.5 meter. So this also indicate as X. So here we see that there is a moment, there is two moment, then and also V2. So we have to find M2 and V2. So same as the part 1, we see that the counterclockwise of moment is positive, and also the downward force for shear is positive. So for moment, the total moment is equal to negative 85. We move from the left to right. So negative 85x plus 3.75, where is the moment at C, then plus 75 times by x minus 0.25 plus M2. X minus 0.25 we will get for the position of C towards the moment at M2. So M2 is equal to 10x plus 15. So for the shear force, the total is equal to negative 85 plus 75 plus V2 equal to 0. So V2 is equal to 10 Newton. Okay, so for the third part, we take range between 0 until 0.75 and indicate also as x. So here the total moment and also the direction for force, total force is counter, for the moment counterclockwise is positive, and for the shear force it is downward positive. So here from the left to right, for the total moment we can see that negative 85x plus 75 in bracket x minus 0.25 plus 3.75 the moment at C plus 75 bracket x minus 0.5 plus 3.75 the moment at D plus M3 equal to 0. X minus, for the x minus 0.25 and x minus 0.5 we can get it by, for the position of C and D towards the M3. So we get after being calculated, M3 is equal to negative 65x plus 48.75. Then for shear force, we get negative 85 plus 75 plus 75 plus V3 equal to 0. V3 is equal to negative 65 Newton. Okay, so next we will move to shear and moment bending diagram. Here we can see that on the first diagram, where is a shear diagram, we got that it is 85 Newton, then it's come down to 10 Newton, and lastly it will go to the negative 65 Newton. So we can see here at the moment where 85 turns to 10 and 10 turns to negative 65, it is the value is 75 Newton is equal to the value of the force at C and D. So next is for the moment diagram, bending diagram, where we get for the M1 is positive, so it will incline 80 on the value of 85, because 85 is 8 coefficient for the gradient. Then for the M2 we get it's 10x plus 17.5, so it's more it is lesser than 85x, so we have the coefficient of 10, so it will it will incline slightly lower than M1. So then for the M3 we get it negative 65 x plus 7.25, so it will decline until 0 position back, because it will go to its initial position. Okay, that's all from us. Thank you.